We will see the topic Laplace transform. So we know when you try to analyze a system in time domain, that analysis is very difficult when compared to the analysis in frequency domain. So always for analyzing the system, it will be very easy if you convert this time domain representation of the system into frequency domain and analyze it. So normally how we do is that we will be representing the input-output relation of a linear time invariant system using a differential equation, and that particular differential equation will be analyzed for any given input. You can find the value of output. So if you convert this in frequency domain, this analysis is very, very simple. Now, Laplace transform is a mathematical tool which is used for converting time domain representation of this differential equation into frequency domain representation or algebraic equation, or you can say it is used for converting any signal represented in time domain to frequency domain. So Laplace transform is a mathematical method which is used to convert differential equation into algebraic equation. And how it is done? This is done with the help of this particular equation. Laplace transform of a time domain function x of t. Laplace transform x of t is represented as x of s and is given by this equation. It is equal to integral minus infinity to plus infinity x of t e raised to minus st dt. Now, if you integrate it from minus infinity to plus infinity, it is known as bilateral Laplace transform. And if you are integrating it from 0 to infinity, it is known as unilateral Laplace transform. And this is a transform that we commonly use. And what is this S? S is a complex variable and it is having a real part and imaginary part. It can be represented as sigma plus j omega. Now, whenever you try to convert this time domain representation of a signal or anything into frequency domain or a Laplace transform representation, you have to always, along with this Laplace transform, you have to write the region of convergence of this particular transform. Now, what is meant by region of convergence? Now, for um, for some values of s, this value that is minus integral minus infinity to plus infinity x of t raised to minus st dt will not converge. That means the value of this particular equation will become infinity for some values of s. So we have to find the values of h for which this particular term converges, or this particular term or this particular integral is finite value. So that points are known as region of convergence. So region of convergence is a set of points in the S-plane for which the integral on the right hand side of equation x of s converges. Okay, now this region of convergence we have to always specify with respect to Laplace transform. Otherwise, when you try to find the inverse Laplace transform of a particular signal, it will not be unique, or this inverse Laplace transform you can get the when you try to convert time domain representation of a signal into a Laplace transform. For certain signals you will get the same Laplace transform. So when you try to get the signal back from the inverse Laplace transform, you will not be able to correctly identify what is the time domain representation of this particular signal. So we will see in the next video what is the significance with the help of an example. So please understand this ROC has to be always specified along with Laplace transform. Otherwise, you will not be able to get the Laplace transform representation or time domain representation from inverse Laplace transform.